Welcome to the Deep Dive. Today, we're locking in on the tech that's fueling all the buzz around the new game, Doom, the Dark Ages.
Yeah, it's pretty exciting stuff.
Totally. We've got a really interesting set of articles here, straight from NVIDIA, and also a PC Mag piece breaking down the top graphics cards for 4K gaming next year, 2025. So our mission basically is to cut through the technical jargon and really understand how the latest leaps in graphics tech, things like ray tracing, DLSS, how they're changing the game, literally changing the game.
And Doom. The Dark Ages seems like the perfect lens to view that through, doesn't it?
It really does. The early chatter, even just in this early access phase, it's hard to ignore.
Yeah.
And like a lot of that excitement seems focused squarely on the tech side.
It does. Sounds like Aid Software and NVIDIA have really pushed the boat out here.
For sure. The hype is definitely real. We're seeing early reviews pop up already. And yeah, the tech is getting major props.
What are they saying?
Well, people are throwing around phrases like NVIDIA's tech being a performance BFG, you know.
Ah, nice Doom reference.
Right. And a match made in heaven with the id Tech 8 engine, calling the game the poster child for DLSS 4.
Wow. Okay, so poster child for DLSS 4, technical triumph. That's some pretty strong praise right out of the gate.
It is, and it really highlights what we want to dig into today. How NVIDIA's hardware, their GPUs, and their software are like working together.
Yeah, how they mesh to deliver this kind of next level experience. And importantly, what does this mean for you, the person actually playing the game? You know, what are the real benefits?
Okay, so let's jump right in with the launch then. Doom. The Dark Ages is currently in early access, right? For premium edition buyers and people who got those new RTX 50 series bundles.
Correct. The full global release is set for May 15th, 2025. So just around the corner, really.
Those early adopters must be seeing something special there.
Seems like it. And it's interesting that this early access is tied to the higher-end NVIDIA stuff. Sort of suggests a deliberate strategy, maybe? Showcase the cutting-edge visuals from the start?
Makes sense. And those rave reviews we mentioned, Games Radar, Plus Gamerant, PC Gamer, DSO Gaming Trend, they really hammer home that positive first impression about the NVIDIA tech.
Definitely.
So it's got to be more than just having a beefy graphics card, right?
Yeah.
What exactly is NVIDIA doing under the hood in Doom, the Dark Ages?
Right, exactly. The game uses something called native id Tech 8 ray tracing. So ray tracing, think of it like simulating how light actually works in the real world.
Okay.
It traces the path of light rays, bouncing off surfaces, bending through glass, creating more realistic reflections, refractions, shadows, all that good stuff.
And NVIDIA's cards have specific hardware for that.
Yep, the GeForce RTX ray tracing cores, they're like dedicated parts of the chip specifically built to handle those really complex light calculations efficiently, so it runs in real time.
Got it. Now, here's where it gets really interesting, I think. I heard about something called path tracing. That's coming in an update. What's the difference between that and the ray tracing that's in there now?
Yeah, good question. Path tracing is essentially, well, it's like ray tracing turned up to 11.
Okay.
If ray tracing simulates some key light paths, path tracing tries to simulate virtually all the ways light can travel and interact in a scene. It bounces rays around much more comprehensively.
So even more realistic light.
Exactly. It leads to more accurate, more physically based global illumination, basically, how light bounces around and lights up the whole environment, not just direct light and shadows. I think ray tracing is focused beams, path tracing is kind of the whole light show.
Wow, that sounds incredibly demanding, though, like computational.
Oh, it is. Massively demanding. And that's where another piece of NVIDIA tech comes in. DLSS ray reconstruction.
Okay, what's that?
So when you do all that intense path tracing, the raw image can look kind of noisy, visually grainy. Traditionally, engines use things called denoisers to clean that up.
Right.
But denoisers can sometimes smudge the details, make things a bit blurry. DLSS ray reconstruction uses an AI model instead.
AI again.
Yep. This AI is specifically trained to intelligently clean up that path tracing noise. The result: a clearer, sharper image, and crucially, it does it more efficiently than traditional methods, helping keep performance playable even with path tracing enabled.
So AI is making this super realistic lighting actually practical for gaming. That's pretty wild.
It really is.
I also saw NVIDIA Reflex is integrated. What's that doing for gameplay?
Reflex is all about responsiveness. It reduces system latency.
Okay, latency. So the delay between clicking the mouse and seeing the action on screen.
Exactly, that delay. Reflex minimizes it, making the game feel snappier, more immediate, which, in a super fast-paced game like Doom, that's a huge plus. Makes aiming feel better, movement feel tighter.
Okay, yeah, that makes total sense for Doom. Now let's dive into something that's getting a ton of buzz. DLSS 4 with multi-frame generation. That sounds like some serious next-gen stuff.
It really is a significant step up. You probably know DLSS already, right? Uses AI to upscale a lower res image, make it look sharp like native resolution, but boosts your frame rate.
Right, DLSS super resolution.
Exactly. So DLSS 4 builds on that foundation, but adds this multi-frame generation. Here's the kicker. For every single frame your graphics card traditionally renders.
Yeah.
DLSS 4 uses AI to generate 3 additional frames in between.
Wait, 3. 3 AI-generated frames for every 1 rendered frame.
3 extra frames.
Okay, that's not just a little bump. That's a massive performance multiplier.
It absolutely is. It's a huge leap, especially when you're pushing high resolutions and detail settings.
So what kind of frame rate increases are we actually seeing in Doom, the Dark Ages, with this? Like real numbers?
The numbers are pretty staggering, honestly. On the highest ultra settings at 4K resolution, the top card, the GeForce RTX 5090, is hitting over 320 frames per second.
320 FPS at 4K Ultra? That's insane.
That's a 4x performance multiplier compared to native rendering. And even down at 1080p, it's pushing up to 470 FPS.
Wow. What about the other 50 series cards?
Still incredibly impressive. The RTX 5080, over 240 FPS at 4K. The 5070 Ti, over 210 FPS at 4K. And even the, let's say, more mainstream cards are getting huge boosts. The RTX 5060 Ti is hitting over 180 FPS, but at 1440p.
180 FPS at 1440p Ultra on a 5060 Ti. That's incredibly smooth. That covers pretty much any high refresh monitor out there.
Exactly. It makes that super fluid gameplay accessible even on mid-range hardware, which is kind of the point.
What about gaming laptops? They usually have less power to work with.
Even there, the gains are really significant. An RTX 5070 laptop GPU, for instance, is getting over 200 FPS at 1080p.
Nice.
And it can push up to 270 FPS at 2560 by 1600 resolution, which is sharper than 1080p. So yeah, DLSS 4 is making high frame rates very achievable on mobile rigs too.
That's fantastic news for laptop gamers. And I think I read something about VRAM. Even cards with 8 GBs of VRAM can handle these settings because ultra settings usually eat VRAM.
That's right. Apparently, by tweaking just one in-game setting, texture pool size, setting it down to 1536, even those 8 GB RTX 50 series cards can still run ultra settings at high frame rates with DLSS 4.
Huh. So the tech is maybe getting more efficient with memory usage too.
Seems like it, yeah. Which is great news.
Now, all this advanced tech, it needs the right software support, doesn't it?
Yeah.
Tell us about the GeForce Game Ready driver they released.
Absolutely critical. Yeah, NVIDIA dropped a brand new Game Ready driver timed perfectly for the Doom, the Dark Ages early access launch.
Okay.
This driver is specifically optimized to get the best performance in the game on GeForce PCs and laptops. It includes all the necessary support for that native IDTech 8 ray tracing, for DLSS 4 with multi-frame generation, and for reflex low latency.
So basically, you need this driver to unlock all that crazy performance we were just talking about.
Pretty much, yeah. It's the key. But this driver update, it sounds like it's bringing more than just optimizations for Doom, right? There are broader improvements, too.
Exactly. It's not just game-specific. The driver includes updates to the DLSS multi-frame generation tech itself, and also upgrades to the underlying frame generation AI model.
Ah, okay. What do those upgrades do?
Well, this new model is apparently faster, uses less VRAM, which we just talked about, and NVIDIA says it can potentially boost frame rates even further. And that applies to both the older RTX 40 series and the new 50 series cards.
Okay, so benefits even for owners of slightly older RTX cards, that's good.
Yeah.
And the AI models for the other DLSS features got upgraded too, like the upscaling part.
Yep. The transformer models used for DLSS super resolution, the upscaling, and also for ray reconstruction and DLAA, which is their AI anti-aliasing, those are improved as well.
And what do those improvements bring?
The focus seems to be on image quality, better temporal stability, so less flickering or shimmering over time, reduced ghosting artifacts, you know, those trails you sometimes see with fast motion,
Yeah.
and generally bringing out finer details in the image, especially when things are moving.
So sharper, cleaner, more stable visuals overall. Nice.
You mentioned something called DLSS override features in the NVIDIA app. What's the deal with those? Sounds like something for tweakers.
Huh, yeah, maybe a little bit. They're basically tools for enthusiasts who want more direct control. For example, you can manually turn on multi-frame generation in a game, even if the game itself only officially supports the older frame generation.
Oh, okay.
You can also force the game to use the absolute latest DLSS AI models, even if the game hasn't been updated. And you can even fine-tune the internal rendering resolution when using super resolution.
So it's about giving you more knobs to turn, basically, fine-tuning the experience, even in games that aren't, like, fully up to date with the latest DLSS.
Precisely. More control for power users.
Okay, so we're seeing this really tight integration between the hardware, the RTX 50 series, and NVIDIA software, the drivers, the AI models. Now, PCMag took a look at the best graphics cards for 4K gaming in 2025, and unsurprisingly, the RTX 50 series features pretty heavily.
Yeah, no shock there. The NVIDIA GeForce RTX 5090 is highlighted as, well, the best card, period. The cost-no-object choice for 4K gaming.
The king of the hill.
Pretty much. Class-leading performance, all those powerful ray tracing and AI bits we've been talking about, and a massive 32 gigabytes of that super-fast GDDR7 memory.
32 gigs. Wow. And performance-wise at 4K.
PCMag says it can reliably run pretty much any current game at 4K. Max settings hitting at least 60 FPS and often pushing towards 120 FPS or even higher in many titles.
Okay, so that's the ultimate 4K setup. What about a high-end option that's maybe slightly less ultimate in price?
Right. The GeForce RTX 5080 is also called out as an outstanding choice for 4K. Comes in at a, let's say, more competitive price while still offering those powerful AI features and delivering really strong performance overall.
And both of these are based on the new architecture.
Yep, both built on NVIDIA's Blackwell architecture, and they feature the 5th generation Tensor Cores. Those are the bits specifically designed for AI processing, and they provide significant boosts there, which is exactly what powers DLSS 4.
It's super clear that DLSS 4 is a massive selling point for these 50 series cards. Let's dig just a little deeper into the tech that actually makes this multi-frame generation possible. You mentioned Blackwell hardware and AI software.
Right, so multi-frame generation really relies on that combo. The new AI model that generates those extra frames, it's significantly faster and needs less VRAM than the previous frame generation model used in the 40 series.
How do they make it faster and more efficient?
Well, one key innovation is replacing dedicated hardware for something called optical flow analysis.
Optical flow that predicts pixel movement between frames.
Exactly. They've replaced the dedicated hardware optical flow accelerator with a more efficient AI model to do that prediction. Using AI for this part actually reduces the overall computational cost of generating those extra frames.
So AI is optimizing the AI process itself. That's kind of meta.
Yeah, it's pretty advanced stuff. And you mentioned the Blackwell GPUs have something called hardware flip metering. What's that about? Is that related?
Yes, it is. So to make sure the experience with all these generated frames feels smooth and not like jittery or uneven.
Right, frame pacing is important.
Exactly. Blackwell GPUs include this hardware flip metering. It essentially gives the display engine itself more precise control over when each frame is actually shown on your monitor. This helps manage the presentation of those AI-generated frames alongside the traditionally rendered ones much more accurately, leading to smoother perceived motion.
Gotcha. Better frame pacing for generated frames.
And this new transformer model you mentioned for DLSS, it's not just for multi-frame generation, right? It helps the other stuff too.
Correct. This upgraded transformer model, which, is also used for ray reconstruction and super resolution, it's a big architectural improvement. It uses a technique called self-attention.
Self-attention?
Yeah, it basically allows the AI to look at the entire scene and even information across multiple frames to better understand context. This leads to, like we said, better image quality overall, more stability, less ghosting around moving things, better detail preservation during motion, smoother edges on objects.
Sounds like a major upgrade to the core AI then.
It is, and interestingly, NVIDIA says this is the first real-time application of this kind of transformer architecture in graphics, so it's kind of a landmark in that sense.
That's pretty cool.
Yeah.
And the really great thing is, all these DLSS 4 advancements, these new models, they still work with older games that already have DLSS. You don't need a specific DLSS 4 patch for every game.
That's the plan, yeah. DLSS 4 and these new models are designed for backwards compatibility with existing DLSS integrations. And like we mentioned with those override features in the NVIDIA app, you can even potentially bring some of these benefits, like using the newer models, to games that haven't been specifically updated yet.
Okay, that's really good to hear. Now, it's not just NVIDIA pushing things forward in Doom. The Dark Ages, is it? The game engine itself, id Tech 8, has seen some big improvements too.
Oh, absolutely. You can't discount id software here. One of the really key enhancements in id Tech 8 is a brand new data streaming system.
Data streaming, what does that mean?
Okay, so instead of loading like the entire game map into your computer's RAM, your main system memory, Tech 8 breaks the maps down into much smaller chunks or sectors. It only loads the sectors it needs right then.
Ah, okay. And the benefit is
Dramatically reduced RAM usage during loading, and the result is incredibly fast loading times, like seriously fast. One outlet, I think it was Eurogamer, even said they almost wondered if loading screens were even necessary anymore.
wow, that fast. Faster loading is always good, but you hinted this might actually affect gameplay too.
Yeah, it kind of does, indirectly. Think about Doom. You die a lot, especially on harder difficulties. Guilty, right. So with these super quick load times, the time between dying and getting right back into the action is significantly shorter.
Less downtime, less frustration.
Exactly. It can actually encourage you to be maybe a bit more persistent, try riskier things, especially on those tougher settings where you know you're going to die frequently. It keeps the momentum going.
Okay, yeah, I can definitely see that making a difference in a game like Doom. Okay, we've talked quite a bit about ray tracing and then path tracing. Let's just make sure we nail down the core difference for everyone listening.
Sure. So basic ray tracing, right? It's about casting rays from the camera, from your viewpoint, out into the 3D scene.
Okay.
And it simulates how those rays interact with objects bouncing off mirrors, bending through water, being blocked to create shatters. Modern GPUs have dedicated hardware that makes this possible in real time for games.
Got it. And path tracing is the more intense version.
Exactly. Path tracing is more computationally heavy because it's trying to simulate light in a way that's much closer to actual physics. It traces many, many more light paths, letting them bounce around the scene more randomly, more naturally, until they hit a light source or reach some limit.
So it's trying to capture all the light bounces, not just the main ones.
Pretty much, yeah. The goal is much higher fidelity global illumination, a really realistic simulation of how light actually behaves and fills a space. And Doom. The Dark Ages plan to add path tracing after launch, using DLSS ray reconstruction to keep it running smoothly. That'll be a fantastic showcase for this advanced technique.
So just to boil it down, ray tracing traces key light paths for specific realistic effects, like reflections and shadows, from the camera's view.
Yep, efficiently tracing from the eye back. Recursive ray tracing adds more bounces for reflections and refractions.
While path tracing tries to simulate almost all the possible ways light could travel and bounce around the whole scene, starting from the light sources, for ultimate realism.
That's a really good way to put it. It simulates the whole journey of light for a more complete, physically accurate lighting result. It's a big step up from older techniques like rasterization, especially for those complex light interactions.
Man, it's just incredible how far graphics tech has come. Doom. The Dark Ages really does sound like it's pushing right up against the boundaries of what's possible right now.
It truly does. The deep integration we're seeing between NVIDIA's new RTX 50 series GPUs and Tech 8, leveraging native ray tracing, the promise of path tracing boosted by AI ray reconstruction, reflex for low latency, and especially DLSS 4 with that crazy multi-frame generation. It really feels like a significant marker for real-time graphics in gaming.
All right, let's try and wrap this up then. Key takeaways from this deep dive. I mean, The Dark Ages clearly isn't just another sequel. It's a real showcase for NVIDIA's latest hardware and software.
Definitely.
We're seeing these incredible performance leaps thanks to DLSS 4. Stunningly realistic visuals with the advanced ray tracing and their upcoming path tracing, and even those super fast load times from the Tech 8 engine improvements. And ultimately, all of this stuff, it just translates directly into a much better, much more immersive gaming experience for you, the player.
Yeah, and for me, the real aha moment here is just seeing how tightly integrated the hardware and software have become. Especially those AI-powered features, multi-frame generation, ray reconstruction. It's clear AI isn't just, a buzzword anymore in graphics.
Right.
It's becoming this fundamental tool that's really revolutionizing how games look and perform in real time. It's dramatically expanding what's actually possible.
So as this kind of visual fidelity, this incredibly smooth performance, and these instant loading times become, more common, more accessible.
Yeah.
It really makes you wonder, doesn't it? How is this going to reshape how we experience virtual worlds, interactive entertainment in the next few years?
Yeah, what new kinds of games or gameplay experiences might even become possible when these technical barriers keep getting smashed down?
Exactly. Definitely something to think about. Well, that's all the time we have for this deep dive. Thanks for tuning in.
The Makers felt a weapon as powerful as the Slayer should be guided.
lied to us. And now he has a leash.
He's not one of us.
Our enemy is divided. The time is now.
They fear him, and so your dominion over hell is not absolute.
Avoid the Slayer. Focus on breaking humans first.
That demon, he's after something. That much power in Hell's hands. None of us would survive. Bishop Creed, we need him.
Launch the Slayer.
Impact confirmed. The Slayer has been activated.
I can never rule as king, so long as you are the only one they fear.
Stronger than maybe even you.